it is usually most useful to condense log expressions rather than expand log expressions. That is, to write the sum or difference of two or more log expressions as a single log expression. To condense a log expression, we basically do the reverse of what we did to expand a log expression. First, we use the power property, followed by the product and quotient properties. So example 5, write as a single log. Part A, I have the log of 2 base 4 plus the log of 32 base 4. Okay, so the reverse of the product property says if we're adding two logs together, they can be condensed into one single log. Since we are adding, we would want to multiply 2 and 32, and the base remains 4. 2 times 32 is 64, so this is the log of 64 base 4. And again, anytime you have the log of a constant number, it's a good idea to see if it simplifies further. 4 squared is 16, 4 to the third power is 64. So log of 64 base 4 simplifies all the way down to 3. Example 5b, the log of 4x minus 3 minus the log of x. So here we have two logs that are subtracted, and so the reverse of the quotient property says if you're subtracting two logs, you can combine them into one single log by dividing the inside expressions. So this would condense into the log of 4x minus 3 over x. So now one single log. Example 5c, 1/2 the log of x plus 4 log of x minus 1. So on this problem, we have factors in front of our logs. So we'll want to start with the power property first. So 1/2 can be brought in as an exponent on x, log of x to the 1/2 power, plus 4 can be brought in as an exponent on x minus 1, plus the log of x minus 1 to the 4th power. Okay, remember that 1/2 as an exponent is the same thing as a square root. And now that the power property is done, we can go to the product and quotient properties. Here we have one log being added to another log. And so the reverse of the power or product property would say to combine these into one single log, we would want to multiply the insides. So this would be the log of the square root of x times x minus 1 to the 4th power. Example 5d, we have 3 natural log of x plus 7 minus the natural log of x. Okay, so we have a factor in front of the natural log. So the first thing to do is bring 3 in as an exponent on x plus 7. So this becomes the natural log of x plus 7 cubed minus the natural log of x. Here we have two logs subtracted, and so reverse of the quotient property says we can condense these into one single log by dividing the insides. So the natural log of x plus 7 cubed over x. And lastly, example 5e, 4 log of x base 5 minus 2 log of 6 base 5 minus 1/2 log of y base 5 plus 1/3 log of 2x minus 5 base 5. So we have a lot of factors here. So we'll start with the power property. So power property, we'll bring the 4 in as an exponent, log of x to the 4th power, base 5, minus 2 can be brought in, the log of 6 squared, base 5, minus 1/2 brought in as an exponent, the log of y to the 1/2 power, base 5, plus 1/3 brought in as an exponent, 2x minus 5 to the 1/3 power, base 5. Let's do some final simplifying, and then we'll move on to the product and quotient properties. So this log is okay. This log, 6 squared is 36, so let's change that to 36. This log, y to the 1/2 power, is the same thing as the square root of y. And our last log, 2x minus 5 to the 1/3 power, is the same thing as the cube root of 2x minus 5. Okay, now we move on to combining this into one single log using the product and quotient properties. So how that will work is any log that is added will go into the numerator. Any log that's being subtracted will go into the denominator. So this will be one single log with base 5 of, no sign implies positive, so x to the 4th in the numerator, minus the log of 36, so 36 goes into the denominator, minus the log of the square root of y, so the minus tells me the square root of y should go into the denominator, and now a plus, that tells me put in the numerator the cube root of 2x minus 5.